My name is Chris Melson, and I'm the program manager of Tran-SET, which is a university transportation center that is administered and led by the Louisiana State University. It's a regional UTC, so encompasses states in the south central U.S. This presentation is over one of our funded collaborative projects between Oklahoma State University and Louisiana State University, as well as the Louisiana Transportation Research Center. Thank you for attending this webinar. If you are curious about the type of research that we administer and fund, I'd ask that you can go to our website. We have all the information about the research that we do fund. There's 2 to 3 page project sheets for each project. Admittedly, the majority of the research is actually more geared towards the infrastructure-based fields, such as asphalt and concrete. But again, being as a regional UTC, we have to address regional priorities. And one of them, of course, is traffic and congestion mitigation. The presentation will most likely last around 40 minutes, and I ask that you hold your questions until the end. There's a Q&A box. You can type in your questions in that box, and at the end of the presentation, we can start from those questions. And I think without further ado, I'll turn it over to Dr. Ahmed from Oklahoma State University.
Thank you, Chris. Again, as Chris mentioned, this is a project that was sponsored by Tran-SET. The problem statement itself was identified by the advisory group for the UTC. We took the problem statement that they gave us, which was just briefly defined, not well defined, and we prepared, elaborated on it, and we started the work about sometime in January, February of 2017. The project, myself, my name is Samir Ahmed from Civil Engineering at Oklahoma State University. One of the PIs was Dr. Isaac. He left LSU, went to another university. Then we have Dr. Osama Osman. He was with LSU throughout most of the project. Now he is with Virginia Tech Transportation Center. Then we have Dr. Kojo. He was with LTRC. Also, he was with LSU. Now he is with, I think, University of Louisiana Lafayette. All right. The project is entitled Mitigating Traffic Congestion in Baton Rouge, Supply and Demand-Oriented Strategies and Treatments. We'll go over just some general background. Again, the purpose of the study is to identify treatments and strategies with emphasis on the bridge, Mississippi River Bridge, the I-10 Mississippi River Bridge. The I-10 corridor is one of the heavily traveled coast-to-coast interstates. It carries a large number of trucks and has been identified as a freight corridor. The portion of I-10 that goes through Baton Rouge was constructed in 1960. It's a 4-lane freeway, so it means 2 lanes per direction. The bridge also, the Mississippi River Bridge on I-10 is also 2 lanes per direction. This here will help serve what are the issues that are there right now. This here is I-10. And this here is the Mississippi River Bridge. So it's the only freeway link between east and west Baton Rouge compared to the relative to the river. We have here the connection between I-12 and I-10, the junction, the merge. There has been improvements here and there, geometric improvements. So that did divert more traffic to the core of the urban area. So these two, more traffic now is coming in here, and they need to use the Mississippi River Bridge, the I-10 bridge. There is an older bridge on the US 61, US 190 corridor in here. However, since the I-10 bridge was constructed, the older bridge just did not receive the attention that it used to get. Likewise, the corridor, the I-90, I-61, US 61, US 190, also did not receive the necessary maintenance So it's in poor condition. This corridor here to the north is in poor condition. There are traffic lights along that corridor. They are not synchronized and wait times are very long. Most people who are trying to travel from east to west or west to east relative to the river, they prefer to use the I-10 bridge because it provides a direct connection to most significant points of interest. Also, the older bridge and the older route that leads to the bridge, as I said, are not in good shape. So that's the reason that the older bridge is underutilized. So this here are the the problems that we have now. From this point in here on I-10, more or less, to the junction between I-10 and I-12, here we have recurring congestion during the morning and afternoon peaks. And the project was to address that congestion with emphasis on the bridge to see what can be done. This here a picture of the bridge. As you can tell, a large number of trucks traveling and the stop and go conditions in there. Relieving congestion on the I-10 Mississippi River Bridge can be done easily if we have money to construct a new bridge. But a new bridge will cost about $1 billion. That's in maybe 10 years ago, dollars at that time. So that option really is not feasible economically. We were asked to look at other solutions that have not been explored in depth, especially active traffic management, intelligent transportation systems, and travel demand management techniques. And that's the focus of our work, these applications in here. Just to give you an idea about previous work done to address congestion on I-10 and the Mississippi River Bridge, there were studies and the projects proposed for the I-10 corridor itself, and the projects also proposed off the corridor, the roadway network beyond the corridor. Examples of I-10 corridor projects, there is the I-10 Baton Rouge Major Investment Study. It was sponsored by Louisiana DOTD in 2000. There is the National I-10 Freight Corridor Study. Again, that was a national study. FHWA and LDOTD participated in it. There is the LDOT also I-10 Corridor Improvements Stage 0 Feasibility Study. This is a more recent one. So these are the major ones that address the corridor itself. These are examples of the cover pages of these studies. They are available on the web. This is something recent that I have seen about capacity improvements to the I-10 corridor. That's here east of the bridge. So there are 3 stages in there proposed. Primarily, it's widening the I-10 from 4-lane to 6-lane, adding 1 lane per direction, eliminating some on-ramps and off-ramps and rebuilding them, new ramps to eliminate weaving and excessive lane changing. These improvements are along a 3.5-mile segment of the I-10 corridor. The expected cost, according to the publication, it's $350 million. This here is stage 1. It addresses the exits at Washington Street, at Dalrymple Avenue. Some exits and on-ramps will be removed, and the new ones will be constructed. That's in addition, again, to the widening of I-10. This is the second stage, again, that will be removed and new exits and will be modified in here. And this is the third phase of the of that proposed capacity improvement. Now, off-corridor projects, there was a number of them. One of them is adding or constructing a new bridge south of the I-10 bridge. As I said, that proved to be expensive and it's not feasible. There is the Baton Rouge Urban Renewal and Mobility Plan, known as the BUMP study. It's proposed by the AECOM. It's a very interesting study, and we'll talk about it in some detail shortly. There is the West Side Expressway, Louisiana 1 to Louisiana 415 connector, Highway 1 to 415 connector, the Baton Rouge Loop, Northern Bypass. So a number of proposals that are unfortunately just not too much has been done. The second option here, as I said, the BUMP study or proposal, that's really, the goal is to use the old bridge and the underutilized network that leaves without old bridge in order to lessen the demand on I-10 and the I-10 bridge. This here is the BUMP study. Again, as you can tell, it's two, they use the term SIU for segment of independent utility. It means independent. You can have this part separate or this part separate. This here is linking US 61 to I-10, but the rest is improvement to the 61 and 190 corridor, and improvement to the old bridge itself, rehabilitation. The BUMP project, we envisioned this to be a toll road, but it really doesn't have to be. If the funds are available and it can be, finances are available, then it doesn't have to be a toll facility. Also, the existing businesses and land uses nearby, they are going to be served by local roads parallel to the corridor, like a service streets or parallel service roads, to provide the necessary access to this limited access facility, which would be kind of a toll facility. The concept itself is great, but it did not materialize because, again, it was envisioned as public-private partnership, and whether the private sector can get involved on the bridge or not and modify on improving the bridge or not. There are lots of debates there, but nothing was done regarding that proposal. The data available to us when we started looking at the problem was not too much, really. That was a major problem coming up with data. Louisiana DOTD was one of the major sources. We had traffic volumes along with a simulation model, VSIM model, as we'll discuss. It was hourly volumes, 3 hours in the AM peak, 4 hours in the PM peak, and these were used as demand inputs in VSIM. Streetletics, which is part of City Labs. Again, there were traffic volume data, 3 hour AM, 3 hour PM, aggregated volumes. They were used in calibrating and validating the simulation model. Then we have the National Performance Management Research Data Set. This is a national data set that's maintained by the FHWA. We used that to come up with travel times and the speeds, which again were needed for calibration and the validation of the same model during the AM and PM peaks. Then data was also obtained from the city of Baton Rouge and the Louisiana DOT regarding traffic signal schedules and timing. So we use that again in the calibration and the validation of VSIM. Later on, as the project was about to come to an end, we heard that the Capital Region Planning Commission was collecting data. So they were collecting data that we could have used if it was available to us. But unfortunately, that effort is still going on, and we did not have the opportunity to use their data. As I said, there is a simulation model, microscopic simulation model, VSIM platform. It was available from Louisiana GOTD. We acquired it. And there were some hourly volumes encoded into that model. It was partial model, not a complete network, just for I-10 and the segments east and west of the bridge. But the segments that lead to the old bridge, these were not part of the model. The model served as our primary tool for testing and evaluating alternative solutions or recommendations. The data obtained from the other three sources, Streetletics, the NP National Performance Management Data Research Set, and the traffic signal data. These were used again in the calibration and the validation of the model. The treatments and the strategies that we explored, these were identified by the investigators, the PIs, with some discussions with the stakeholders at LGOT, Louisiana GOT, and the Louisiana Transportation Research Center. We have the first category of treatments. It's supply-oriented, meaning adding capacity primarily or eliminating bottlenecks. And then demand-oriented, which has to do again with either metering the demand or finding alternate routes so to divert some of the demand to an underutilized corridor. For the supply-oriented measures, we had one of the proposals or the alternatives that we explored was again to address the junctions, the exit ramps at Washington Street and Del Rampel Avenue. The exits there to I-10, they were very close, lots of lane changing and the queuing developing and come back up to I-10 for long distances. So that was one of the proposals that we explored. The other one had to do with improving the corridor on US 190 and US 61 and rehabilitating the old bridge so it can carry heavy trucks. And this again was examined in our simulations. For these two, the modes affected are passenger cars and the trucks and the transit. For demand-oriented measures or treatments, we have ramp metering, particularly west of the bridge at the Alexander Avenue on-ramp. So metering the demand there, that's lots of heavy traffic coming to I-10, local traffic. And then overall local traffic demand management, which will be just in the form of telecommuting, improving transit services and the schedules, encouraging bike lanes, flex hours, staggered hours, improving or promoting land use planning, because again, lots of land uses, you have to travel from East Baton Rouge to West Baton Rouge for no good reason, or just because again of land use issues. So they take transportation and the traffic into consideration when they make these developments, proposed developments. That definitely will help lessen the problem. The last demand-oriented proposal we explored was reduction in truck traffic. This here may be more theoretical and not very practical. It's primarily to work with the industries, local industries, so that they will keep their truck traffic off the road during the AM peak and then they can use the network during the off-peak. It's just like rescheduling of how trucks arrive and leave the plants and the industries and that core of Baton Rouge. The measures of effectiveness and the metrics that we used or we computed from the simulation model and we used to evaluate the alternatives: average delay seconds per vehicle, the throughput, which is vehicles volume kind of, total delay, vehicle hours, vehicle miles of travel, the annual cost of delay, how many dollars per year, and the economic savings, annual economic savings per year, which will be comparing the cost for a given alternative with the cost associated with the do nothing, and that will give us kind of savings. In computing the economic savings, we which we call it user cost, we took the delay in vehicle hours, multiplied it by 1/2 of the average hourly wage in Baton Rouge. The average wage was $21.38. It's customary when you compute delay, the savings in travel time, use 1/2 of that wage. So 1/2 of this times the vehicle hours that give us the user cost. So the user cost associated with the do nothing and the user cost associated with any of the proposed alternatives, these two gave us the annual economic savings. The simulation results, this here is a summary of what we came up with. Minimizing turbulence and the queuing at the Washington Street exit and the Ramble exit. We found that really that option will not solve the problem too much. It's low impact on reducing congestion. And the reason is that the two exits are very close to each other. So closing one of them, diverting traffic to the other, still the queuing will develop and go back to I-10. The cost of this kind of treatment, of course, is low. The barriers to implementation may be public acceptance and difficult to implement to shut down the Ramble exit completely during AM and PM peaks. And then the concept that was presented by the pump study, which is improving the US 190, US 61 corridor and the old bridge. The impact here was high. It can provide high relief in congestion. We did not do statistical analysis because we did not have the data available, but relatives, in terms of when we say low, high, medium, these here are relative terms. This here will improve mobility and traffic flow, improve capacity, because you are adding capacity to an underutilized corridor, reducing congestion overall for the whole network, reduction in delays. The cost compared to other capacity improvement options, it's medium. It's still expensive, but it's not like new bridges to start with. And if it was done like a toll road, as originally conceived, then of course that will be one way to finance this kind of improvement. Barriers and for this type of proposal include limited elected leader support. When you talk about toll roads, and that's just sometimes try to stay away from that. And the lack of funding, of course, because again, you have to do improvements to the bridge and to the underutilized corridor there. Then the demand-oriented measures, ramp metering, again, west of the bridge, it provided medium impact on congestion. It will improve traffic flow and the safety, reduce congestion. Cost will be low, but here public acceptance may be an issue again, because again, the local traffic will not have access to I-10 during the peak hours. local traffic demand management, which, as I said, can be in terms of ride sharing, improving transit, land use planning. The impact can be very high and the cost is low. But again, you have to have public acceptance and employer or agency buy-in. So for, say, the employer to let their employees do their work, say, by telecommuting or staggered work hours, they have to buy into this kind of proposal. Then reduction in truck traffic, as I said earlier. Here, would like to limit truck traffic during the AM peak period, that's eastbound. That will require cooperation of local industries and the businesses. May be difficult to do if we don't get that support. Its impact on congestion will be medium. It can lead to reduction in congestion and reduction in delays to travelers and the shippers. The cost is low. There are numerous tables and charts in the report, which will be available online shortly, I think. And I can't show all of that here because that would be too much. But the conclusions from the metrics that we computed include the following. We have to have combination of both supply and the demand-oriented strategies and the treatments. Supply alone may not do it, demand alone may not do it, but we have to have balanced approach that employs both supply and the demand kind of treatments. Rehabilitating the old bridge, Mississippi River Bridge, and reconstructing the US 190, US 61 corridor really will do a great job if it can be implemented. To produce notable reduction in vehicle hours of delay and to relieve the congestion on I-10 and the I-10 bridge in the core area of Baton Rouge. Implementation of local traffic demand management, telecommuting, transit, etc., can produce immediate reduction in travel delays or traffic delays on I-10. But as I said, it just requires public acceptance and employer participation. Ramp metering at the Alexander Avenue ramp. I think there is ramp metering there now. I did not know about it when I wrote the report, but I understood that later. So ramp metering here can again result in notable reduction in delays during the PM peak. Reducing the truck traffic during the AM peak, going from west to east at the Alexander Avenue on-ramp. This again can produce medium results, notable results, but again, it's just industry acceptance and the scheduling the trucks, we have to buy into that. There's an important caveat that we need to be aware of, that the data available to the researchers for calibrating and validating the model were very limited. Therefore, additional data really need to be collected, and some data are being collected now, as I said. We need to have more information on traffic flow rates, average speeds, traffic density. We need to have information on demand, traffic demand or travel demand data, traveler preferences, perceptions in terms of route choice, mode choice, etc. We need that kind of data in order really to validate the metrics, the numerical values of the MOEs and the metrics that are included in the report. I think that's the presentation, and I would like to entertain any questions.
There is a question in the Q&A pod, which I'll read. It's from Hong Wu, who is a modeler at the Capital Region Planning Commission here in Baton Rouge. And he asked, what year's NPM RDS data was used in your analysis?
The data that we used here, I think it was 2016. But let me verify that. That's in the, I think it's 2016, but I can get to the report quickly. And the reason for us not to use the latest NPR, National Performance Data Management set, that's currently available, was that we had to be consistent. Some data were obtained from Louisiana DOT, some data were obtained from Streetletics, so we had to have a baseline. So that year we had to be consistent, not use data at different time periods. But to answer your question, I should be able to get that here.
Just to chip in as well, I think yes, it's 2015 data we used.
I'm sorry, I could not hear the question very well.
No, it's me. It's 2015. I'm just confirming with you that it's 2015 data.
So I noticed that ramp metering was a treatment that you looked at during your simulation.
Yes.
Did you use a basic fixed timing kind of ramp metering, or was that a little bit of a smarter ramp metering based off of traffic conditions? Or is it basically fixed timing?
I think it was pre-timed, the basic ramp metering with a queue length override. But it was not the dynamic metering that's currently available. No, we used just the basic ramp metering, a fixed rate.
So another question from Pong Wu, and he asks, have you used peak hour excessive delay, PHED, for measuring or comparing traffic conditions in the area?
Well, it depends on what we mean by traffic conditions in the area, where the emphasis, as I said, was on the bridge, how to address the recurring congestion on the bridge that leads to queues that spill to the surrounding roads. The metrics we computed were really for users of I-10, okay, for the corridor itself. But savings or cost to users outside that I-10 corridor were not incorporated because the model we had was not a full model. It was a partial model that covered only part of I-10, okay? And calibrating and building a new or expanding the model and calibrating it and validating it, that requires lots of time and data and resources. So if we'd like to do that, that project could have been, say, a 2-year project with another, say, $300,000 of funding.
Sounds good. I believe he was asking a specific metric, which I think they use for non-attainment areas, which is called a peak hour excessive delay metric. And it sounds like, obviously, this is kind of a more secluded case study for a specific area, in that you use other metrics, essentially, to measure the traffic condition.
Let me go to the measures of effectiveness. I think it's right here. Okay, these were the measures of effectiveness. We had the average delay, and we used that again. We computed that per hour, and we computed it annual. So these were the metrics that we used. And the way we computed the user cost or annual economic savings were using that dollar value per hour, half of the hourly wage.
I don't see any more questions. Speakers and Dr. Kojo, if you have any final remarks, please go ahead.
I just would like to thank the attendees for joining the webinar. Would love to could have had better data, because the effort was really, it was very, very demanding in terms of time, this project. But it's disappointing when you struggle with data. You don't have what you need to do statistical analysis and reliable type of metrics. But again, we had to work with what we have.
Yeah, I agree. And thank you all for joining in, and thank you, Dr. Ahmed, for taking the lead and steering the boat. Thank you very much.
Sounds good. I echo the thank yous from the panelists to the attendees. Thank you very much for attending the webinar. and have a great rest of your day.